Rational zero theorem. Use the rational zero theorem to list all possible rational zeros for the given function. In order to list all possible rational zeros, we're going to take the factors of the constant term, which is a positive 10, and the factors of the leading coefficient, which is a negative 5. First, list the factors of the constant term. The factors of 10 are 1 times 10, negative 1 times negative 10, 2 times 5, and negative 2 times negative 5. We need to list the positive and negative factors. Next, we'll list the factors of the leading coefficient. The factors of negative 5 are 1 and negative 5, and then negative 1 and positive 5. Next, we'll divide each numerator by each denominator. And we'll just do this in a step-by-step process. So first look at 1, and we're going to divide 1 by each term in the denominator. 1 divided by 1 is 1. 1 divided by negative 5 is negative 1/5. 1 divided by negative 1 is negative 1, and 1 divided by 5 is positive 1/5. Now we'll do the same process with 10. 10 divided by 1 is 10. 10 divided by negative 5 is negative 2. 10 divided by negative 1 is negative 10. 10 divided by 5 is a positive 2. Now we'll go ahead and look at the negative 1. Negative 1 divided by 1 is a negative 1. We already listed a negative 1, so we don't need to repeat that. Negative 1 divided by negative 5 is a positive 1/5. We already listed that, so we don't need to list it again. Negative 1 divided by negative 1 is a positive 1, and negative 1 divided by a positive 5 is a negative 1/5. Again, we already listed those, so we don't need to list them again. Whenever we divide the negative 10 by each of these terms, you'll see that we already listed those answers as well. So we can move on to the number 2. 2 divided by 1 is 2. 2 divided by negative 5 is a negative 2/5. 2 divided by negative 1 is a negative 2. And 2 divided by 5 is a positive 2/5. And as you can see, I accidentally listed the 2 twice, so I can just scratch that out. I don't need to include it in my set. I also don't need to include the negative 2. Now we can move on to 5. So 5 divided by 1 is 5. 5 divided by negative 5 is negative 1, but I already have that in my list. 5 divided by a negative 1 is a negative 5. And then 5 divided by 5 is a positive 1, but I already have that in my list. And we can follow this process again with the negative 2. When I divide each of the terms in the denominator by negative 2, you'll see that I already have them listed in my set. And then the same with the negative 5. Whenever I divide my denominators by the negative 5, I have already listed those in my set. So these are all my possible solutions and the answer to my problem.